this is a linear programming problem. The problem states that you are making fruit baskets with oranges, bananas, and apples. The table gives the amount of fruit required for the two arrangements. Each day you have 240 oranges, 270 bananas, and 320 apples. Arrangement A earns a profit of $10 per basket, and arrangement B earns $8 per basket. How many of each fruit basket should you make per day to maximize your profit? So let's start with a profit equation here. So the problem tells us that we make $10 per basket A and $8 per basket B. So that amount times how many baskets we sell, if we add those all together, gives us the profit. So our profit equation, P equals 10 times A plus 8 times B, and that gives us our total profit for the day. Now we want to maximize this profit, so we want to figure out how many baskets of each kind do we have to sell in order to make the maximum profit. Okay, so now we have since we have our profit equation, we have to find some constraint equations. Now we know that the oranges are constrained by the fact that we have at most 240. The bananas, we have at most 270. And the apples, we have at most 320 available to us. So let's write the three equations here. So we know that 4A plus 6B has to be less than or equal to 240. That's for the oranges. We also know that for the bananas, 6A, so 6 times how many arrangements we have for basket A, plus 6B, and that's how many arrangements we have for basket B. That's less than or equal to 270. The last one, apples, we have 8A plus 6B has to be less than or equal to 320. We actually have two more constraints, and these are kind of obvious ones. In order to make a profit, we have to sell a positive amount of arrangements. And we can't sell a negative amount. So our A has to be greater or equal to 0, and likewise B has to be greater or equal to 0. Okay, so now that we have all our constraints, we want to graph them. Okay, so let's go to the coordinate plane, and let's label our axis. Let's use 10 for each two boxes. Okay, likewise on the y-axis, or in this case, we're going to use A and on the x-axis and B on the y-axis. Okay, so let's plot some constraints. Okay, so the first thing we're going to plot is the A greater or equal to 0 and B greater or equal to 0. So here's our first one. That's A greater or equal to 0. Okay, so here's our B greater or equal to 0. So our arrangement A and arrangement B have to be in this first quadrant. So now we have 3 more equations to plot, and we have different choices here. We can put it in slope-intercept form. We can use the intercepts. So let's do this one with intercepts. So looking at the first equation, so if we look at 4A plus 6b equals 240. If we put in 0 for a, we are going to have 6b equals 240. So b is going to be equal to 40. Likewise, if we plug in 0 for b, we're going to get 4a equals 240. And so therefore, a is equal to 60. So here are our two intercepts. So let's graph our line. So on the x-axis, or a-axis in this case, we have 60. That's one of the intercepts. And for the b's, the intercept is 40. Okay, so we do the same thing for the second equation. So we have 6a plus 6b equals 270. So if we plug in 0 for a, we get 6b equals 270. And so when we solve this for b, it's equal to 45. It's going to be the same thing for the other one. If we plug in 0 for b, so we're going to get 6a equals 45, equals 270. And then a is 45. Okay, so let's graph the second equation. So starting at 45 and going up here to 45. Okay, then we have the last one. So we have 8a plus 6b equals 320. So if we substitute in 0 for b, we get 8a equals 320. So a equals 40. And then if we substitute in 0 for a, we get 6b equals 320. And that does not come out to a nice and even number. It comes out to 53 and a third. Okay, so we're going to also plot this. So let's go back up a little bit. So for the a, it's 40. And we're going up to 53 and a third, which is approximately there. Okay, so now that we have our feasibility region, we want to figure out where is it the maximum. Now our feasibility region, if we look at the region, I'm going to fill it in. So this right here is our region. So all our solutions are within this yellow region. Okay, and also as I look at this graph, I can see where all the vertices are, because remember, our maximum will occur at one of the vertices. So we have a vertex right there at 0, 40. We have a vertex at 1530. We have a vertex at 2530. And we have one more at 40, 0. So right here, we technically have one down here, but we know that's the minimum because that's 0, 0, selling no baskets. That's obviously the minimum. So now we have to check where at which of these other 4 points does our maximum occur? So again, this was 0, 40. This was the 1530. And this is the 25, 20, and the last one, 40, 0. Okay, so we need to plug that into our equation. That's the profit equation. And check which one comes out to the highest profit. So for 0.40, we have 10 times 0 plus 8 times 40. This gives us 320. For 1530, we have 10 times 15 plus 8 times 30, and that's equal to 390. For 2520, we have 10 times 25 plus 8 times 20, and that equals 410. And the last point is 40, 0. So when we plug that in, we get 10 times 40 plus 8 times 0 equals 400. Now, this right here is the highest number, so the maximum occurs at 25 arrangement of basket A and 20 arrangements of basket B.